Our next example is using a different type of chart. This is called a bond enthalpy chart, not an enthalpy formation chart. So this is different. This is what you're going to use in organic, and that's why I wanted to show you. Do you notice that they show you a bunch of different bonds? So that's how you know you're dealing with the bond formation. So when chemical reactions happen, you actually have to break the original bonds before you form new bonds. Like if you're dating someone, you probably should break up with that person before you start dating someone else. That would be a good thing to do. So when you break a bond, think about breaking a stick. When you break a stick, you need to put energy into it, right? So when bonds are broken, energy is absorbed. And that would be an endo process. So we have an endo process. So we put energy in first. When those new bonds are formed, you get energy is released. And depending on the difference between this absorption and this releasing, is whether or not the overall reaction is endothermic or exothermic. Here's an example. Before you spend money, you probably should put money into your bank account. Yes? Endo. Okay? So let's say you put in $100. Okay? And then you go buy something and you spend $80. So $80, 100 went in, 80 came out. So you're still going to be in a positive 20 thing because you put more in than you took out, right? That would be endothermic. But what if you put in $100 and you took out $300? You're going to be in the exo. So that's how if you think of money, that kind of makes sense. So it is a difference between these. The reason I'm making a big deal on this one is not products, which is the product side, minus the reactant side. This is your bonds broken minus your bonds formed. So technically, this one is reactants minus products. You must break those bonds before you form new bonds. So when you see the bond things, you're just going to have to do broken minus formed. Broken minus formed. I actually give you this formula on the test. I'm just hoping you'll pay attention. So heat of formations, products minus reactants. That is the most common that we use in general chemistry. But this is the one that you use in organic because you're going to be drawing structures out in organic. There's not a lot of math in organic, very few, but there's just one little chapter that has some of these bond enthalpies in it. Organic's more memorization than anything else. Okay, so this is the chart that we're going to be using. All right, it says calculate the enthalpy for the combustion of propane. And so I'm going to go ahead and write C3H8 is propane. And on these, I do believe I'm going to go ahead and give you a balanced equation. So I might have you balancing some equations, but I'm going to go ahead and do that for this. So because of this, so this is my problem I've got going on, combustion of propane. Combustion is always adding oxygen, making carbon dioxide and water. You actually have to draw the structures out, and I do believe I tried to draw most of these out for you, especially on your test. So if I draw this guy out, you would see it's 3 carbons in a row. This is where that times 2 plus 2 comes in. Carbon always likes to make those 4 bonds. There. So there's that guy drawn out. That's how that looks. And then this would look like this. It's oxygen. I don't have his other dots on him, but I got 5 of those. So I could either draw 5 of them out, or I could just make sure I remember that there's 5 of those. And I only have 1 of those. Well, it's going to be a little bit more complicated than that. Hold on a second. If I draw out CO2, it's going to look like this. Okay, I actually might draw all three of these out before we can count them. All right, and then water. Of course, we know water looks like that. We know it's got those extra pair of electrons, but I'm going to go ahead and draw that over here. Those electrons, this would be hydrogen bonding. It's definitely a polar molecule, but I'll draw 4 of them out. I didn't draw them. Well, I'm going to go ahead and stay consistent because it's going to bother me. 1, 2, 3. You do not have to draw them out. I'm just drawing them out for emphasis. Okay. So what I would do is I need to find out what kind of bonds I've got. So I got bonds on this side, I've got bonds on this side. I got to break these and I got to form these. Then it's going to be broken minus formed. So on here I've got some CH bonds. Do you see them? And if I count, I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 CH bonds. If I go to the chart and find the CH bond, it's 413. Do you see it right there? So 8 times 4, 13. And I don't know if I can read my writing. I think that says 3304. I might need to check my numbers. I can't really read. Okay, so I got those, but what students tend to miss is the fact that I've got, look here. This is where we make the mistake. I got a CC bond here and a CC bond there. There are 2 C to C bonds going on. And a C to C bond is 348. I'll have my kilojoules off. And that is 696 kilojoules. Okay. All right, so I took care of that structure. These aren't so much fun, but I got to teach you. So then I've got 5 of the O2 bonds. So I've got a double bonded O2. They are in the chart. They're on the chart. Where are they on the chart? Let's pull that chart up and see where that double bond is. Oh, it just wrote O2, 495 there, but a lot of times they'll draw them out. So we've got 5 of those 495s. So we got 5 times the 495 kilojoule. We just got to add all those up. And that is 2475 kilojoules. And this is the sum of, so now I just add those together and I get 6475 kilojoules. That's this side. That's the broken side. Now the formation. So we've got an oxygen double bonded to a C, and there's 1, 2, 3, 4, 5, 6. I've got 6 of those, and those are 799. 4794 kilojoules. That takes care of all those. And then I've got an oxygen to a hydrogen. So oxygen to hydrogen. I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 of those. And that is 463 kilojoules. That is 3704 kilojoules. Now I just add those together. 8498 kilojoules. So now these are formed. These are bonds formed. So it's the bonds broken minus the bonds formed. So we get 6475 kilojoules minus 8498 kilojoules. We would get a negative 2023. How coincidental is that? So this is an exothermic reaction. And so this is using formations. So if I use heat of formations, no, this is not formations. If I use heat of formations, I take some of the products minus some of the reactants. So right side minus left side. If I'm doing bond stuff, this weird bond stuff, I have to add up all the bonds, and it's broken, which is reactants, minus forming. So it is flipped. It is two different charts. Okay, there's not a lot of these on your homework. Most of them are the other type, but I didn't want to make sure I show you there is at least one or two of these on your test. Okay,